Hey everyone, let's take a look at an interesting question from the homework. And I'll go ahead and I'll read this because part of the problem with it is it's got a lot of words. Experts fear that without conservation efforts, an endangered species could disappear from the wild by 2022. Just 100 years ago, there were at least 100,000 of this endangered species. By 2010, the estimated world population of this endangered species was 14,100. The bar graph shows the estimated world population of this endangered species for selected years from 1970 through 2010. Also shown is a polynomial function with its graph that models the data. Use this information to complete parts A through C. And our first task is to find and interpret f of 40. Let's look at this bar graph. F of 40 is 40 years after 1970. That's the population in 2010. That means in the year 2010 there are 14,100 individuals. So in the year 2010, the polynomial estimates, so the polynomial estimates, not the actual values. Let's take a look at the polynomial here. Can we pick that off? I can't eyeball it. But what we are given here is we're given this data for the polynomial. So I'm going to fire up my calculator, and I'm going to run the polynomial into it. Now, because I have a feeling that we're going to have to do this a couple of times, I'm going to store 40 as x, and then I'm going to do 0.78 x cubed minus 24x squared minus 880 x plus 37781, and that's the polynomial that I was given. And I'm going to hit enter. 14,101. So let's put that in as our answer. 14,101 individuals. All right, let's look at what our next task is. Identify this information as a point on the graph of f. So our input was 40. And our output was 14,101. Great. Now, part B. Does f of 40 overestimate or underestimate the actual data? Well, we know that the actual data that was given to us in the text was 14,100. And if we look at the bar chart, 14,100. So that underestimates it. It says it's 90 short. Or no, it's 1 over. I'm sorry, it overestimates the size by 1. I was mistaken. Maybe what I should have done is instead of just eyeballing everything, maybe I should have written out 14,100, 14,101, and then I would look at that and I'd say, oh, -1, it's 1 too many. Alright, so let's check our answer. Great. And lastly, at part C, we're going to use the leading coefficient test to determine the end behavior to the right for the graph of f of x. So the end behavior here, 0.78 x cubed. Let's take a look at that. We have 0.78 x cubed. So the end behavior here is a guy with his hands up, right? Hands in the air. A sub n is greater than 0. Oops, it's cubed, not squared. Let's write down the leading order coefficient, 0.78, and x cubed. We'll write that down too. We'll just write that entire leading order term and we'll say a sub 3 is greater than 0 and n is equal to 3. So that means we've got one hand up in the air and one hand down on the ground. Got a guy disco pointing here. That's our behavior. All right. So, is this going to be useful? The graph will fall. Nope, the graph will rise to the right and will not be useful if the population continues to fall. It's rising, the population is likely falling. It's already overestimated at once. So B is the correct answer. It's not going to be D because if the population continues to fall, this isn't going to be useful. So it's B, not useful if this trend continues, if the values on our bar graph, and take a look at the bar graph's kind of dipping down too, continue to fall. All right. That's that question. Thanks. I'll see you next time.